All right, let's recap section 2, properties of real numbers. All right, did anybody have any questions about how to do these problems? We went over a few of them on Thursday. Like I went over problem number 5, told you guys to reference that formula sheet with all the properties. Nate, did you have any questions on any of these? Or were you pretty good? Andrew, were you? Okay.
I had a question about like 16.
Okay, I'll go over that one. Andrew, were you good? Okay. Anybody else want me to go over any of the problems? Number two, sure, I can go over number 2. Jack, were you good? All right, anybody else at home have any questions? All right, so number 2 was the sentence 3 plus the quantity of 5 plus 2 equals the quantity of 5 plus 2 plus 3. So this one's kind of tricky because you see the parentheses there, okay? And you know, you're kind of drawn to that, right, Mrs. Potts? Is that what you were drawn to? Okay. So yeah, so couple things. The commutative property, associative property, distributive property, and the identity element. So when I'm looking at this, I am like kind of feeling that it's not the identity element, Mrs. Potts, because the identity would be either talking about 0 or 1. So it would be 1 when I'm multiplying, okay, and it would be 0 when I'm adding, and I don't see either of those in this problem. So I would pretty much start out with crossing out B. Then I would go to the distributive property. With the distributive property, what I'm looking for is for something to be given to like each of the variables in it. And I'm noticing, all right, in this particular example, all right, if I have 3 plus the quantity of 5 plus 2, it's not like I distributed the 5 or the 3 to the 5 and the 3 to the 2. So I'm not seeing that. So I'm going to cross out C because I'm kind of believing that it's not that one. And now I got the tough part of A or B. Is it the commutative property or is it the associative property? Now, when I'm trying to determine which one it is, okay, I'm going to look and see what happens. Now, the difference between the two is the associative property is talking about the grouping of numbers changing. Okay, it doesn't matter, you know, kind of like this is what I was talking about with Jordan, is it doesn't matter who she works with. Okay, she's still working, she's still there. Okay, and it's not changing things. So she could work with Liam, or she could work with, who's the other person? Victoria. Okay. Does Victoria watch my videos? Good, because it doesn't sound like you're a big fan of Victoria. Okay. Just judging by that. Could be wrong, but it doesn't matter who she works with. You could work with Liam or you could work with Victoria. Doesn't change the fact that you're working. So when I'm looking up here with number 2, notice my grouping's not changing. What numbers are still together? 5 and 2. Does everybody see that? So I didn't change my grouping. So my answer is A, commutative. And remember, commutative is talking about numbers switching back and forth. If I'm thinking about it this way, 5 plus 2 is 7. So is 3 plus 7 the same thing as 7 plus 3? And the answer to that is yes. All right, good question, good question. All right, now, I'm really glad Emma asked about the open-ended because these are kind of tricky. All right, and that's okay that they're tricky. We can still work through these. So it says Jerry sells a particular type of coin online. All right, you get these commercials like early Sunday mornings. Okay, if you ever leave on your TV, if you guys are up before like 9 o'clock, you're not up before 9 o'clock. Yeah, I can tell. Time you sleep in, Phil? And yeah, you look like about a 10 spot there. Kanye's like, mornings? What? What are those? Right, Kanye? Not a morning person? You mean you like those early mornings, like the 1, 2 o'clock? Yeah, All right, so up here, the amount he charges his customers for the coins includes shipping, okay? Jerry uses the equation shown below to determine the total amount in dollars he will charge for X coins, okay? So it says, how much does Jerry charge a customer for 10 coins? So it says X coins, all right, so that means X is coins, so I have Y equals 32.95 times 10 plus 12.95. So my total cost is going to be Y, right? So I have Y equals $329.50 plus $12.95. Add those two together, and I have my total cost is 5, 14, carry my 1, could be 11, 12, carry my 1, could be 3, 4. I got $342.45. Is that what you guys got? All right. So that's how much it costs for 10 coins. Is that okay with you, Emma?
Yeah.
Now, the next part of the question was, what does 32.95 mean in the context of the prompt? So it's simply this. X was coins, all right, and we're talking about cost, so it's 32.95 per coin. All right. Any questions? All right. And Emma, I'm assuming this is where you had a question, correct, on C?
Yeah, it's like C and D.
Okay, with C, it says Zach and Dave bought some coins from Jerry Online. Dave bought 5 more coins than Zach bought. Explain why it's not necessary to know how many coins Zach bought to determine how much more Dave paid than Zach paid. Okay, so first things first, if we kind of think about this, all right, the first thing I would do is I would just go straight to the math. Okay, so Zach over here, and then I'm going to have Dave over here. And it says this. Zach and Dave each bought some coins. Dave bought 5 more coins than Zach. So Dave would be Y equals 32.95. And then if he bought 5 more coins, that's going to represent X plus 5. And then it was plus 12.95. Emma, do you see where I got that from?
Yeah, I didn't realize we had to like carry over from the first problem.
Gotcha. Yeah. So it's one big continuous problem here. So we can always reference back to the beginning. All right. And then we have Y equals 32.95 times X plus 12.95. So X is just representing, Kevin, the amount of coins being purchased, right? And Dave bought 5 more. That's why there's an X plus 5. Are you okay with that? Now, to figure out why it's not necessary to explain how many coins Zach bought to figure out how much more he paid is this. Over here, Kevin, is there anything I can simplify for Zach? No, there's nothing I can simplify. But over here with Dave, I can. What I can do is I can distribute this 32.95 to this. So I have Y equals 32.95 X. And then I need to know what 32.95 times 5 is. So I'm kind of thinking, because I don't have a calculator on me, right? Do you have a calculator? Oh, you might want to use it. You got one? All right. So do 32.95 times 5. So I'm kind of thinking that's 165 minus 25 cents. So I'm thinking 164.75, like that. Now, let's look at these two. All right, when I'm thinking about it, how much more did Dave buy? Well, look, each equation both have 3295x. Do you see that? So they're the same. They also both have this 1295 for shipping or whatever, right? See that? So how much more did he buy? Or how much more did he pay? There it is, right there. And it came from the 3295 times 5. So Steve paid $164.75 more because, all right, he bought 5 more coins at $32.95. Now, I could go into further detail and say, well, the shipping cost is going to be the same whether you buy 1 coin or 5 coins or 10 coins, right? That shipping cost is $12.95. Does that make sense? Now, each coin costs $32.95. So if I bought 5 more coins, well, it's simple. It's just going to be 5 times that $32.95. And that would be the type of work, Emma, that I would include with this. All right, the last question here says, Jerry has a sale on his website. During the sale, Carrie bought twice as many coins as Lou bought. Carrie's total cost is twice Lou's total cost, okay? Now it says, explain how you know that Jerry charged $0 for shipping during the sale. And this one's kind of like, okay, let's say, it gets more logical, right? Okay, let's think about this. There's 2 things, Delaney, that I could change, right? The cost of the coin or the shipping, right? Or I could kind of do a sale on both, agreed? Now let's think about this. Let's think. Carrie and Lou, right? So we have y equals 32.95. And Carrie bought twice as many coins as Lou, right? So I put in 2x right there. Do you see that? Plus 12.95. You okay with that? So that's the equation that was given to us at the beginning. Lou bought X coins at 32.95 plus the 12.95. Now we talked about this. We have the price of the coin and we have the 12.95. Okay, the shipping cost. And it says that Carrie paid twice as much as Lou. But the thing is this. If I kind of distribute this out, okay, into that, I have y equals. Now, if I do 2 times 32.95, it's like, 2 times 33, which is 66 minus the 10 cents. So it's 65.90. X. And then I have this plus 12.95. And here, I just have this. And what I'm trying to get at is this. At this point, we have to think logically, okay? If I have 65.90x plus 12.95, which is the shipping, right? There's no way it's going to kind of balance out and be twice as much as Lou's at 32.95x. Because notice, this is twice as much as that. But once I add this part to it, it's not going to say that double. Do you guys kind of see that? Do you see how I'm showing my work and trying to justify it? Okay. The only way it could be double is if we took this piece out of the equation. Do you guys see that? Do you see how it's like more logic than math? You have to reason with yourself. All right. The only way it could be double is if he didn't charge shipping. All right. You guys okay with that? There is a more, I guess, complex way, but I'm trying to stay with. You okay, Mr. Fox?
No.
You need a hug because I can write you a pass to the nurse. She's giving out free hugs today.
All right, can you give me one earlier?
Yeah. You know, not COVID appropriate. So, all right. All right, so one thing I want to bring up to you, Jordan, is see the word stop. This seems kind of silly. When we're working on the Keystone, okay, you're going to see like arrows at the bottom. They're going to say go on, go on. So that's going to signify that you keep working until you see that stop sign. Once you see that stop sign, that's where you stop, okay? Like I said, there's going to be two parts to the Keystone. There's going to be the multiple choice, and then there's going to be a open-ended like this. So if you've only done the multiple choice, all right, and then you see a stop sign, maybe raise your hand, be like, hey, am I supposed to keep going? Or is this where I stop? If you have any questions for that. Because remember, if you continue on to the next section, one, you're probably going to get yelled at, and two, you're going to have to sit there for the duration of the next section, which will not be fun. That means like you'll be stuck down there from like, I guess they come in at like what, 7:30 in the morning. You'll be stuck down there from 7:30 till like 10:30, and then you'll have to sit and do the next section, which would be like till almost 1 o'clock. Not fun. All right, do you guys have any questions on that? All right, let's go to the next section here. This section is on algebraic expressions. All right. Let's see, this one is quite a bit longer. All right, so what we're going to do here is Sophie, is it okay if, you know, we work on it together and not have any homework tonight? Is that okay with you? Yeah. Okay. So we're going to start on number one, if that's okay with you. All right. So Sophie said we should do it together and not have homework tonight. And I'm cool with that. So let's start with number one. If X represents an even number. Sophie, can you give me an example of like a couple even numbers? All right, cool. All right, which expression represents an odd number? So, Sophie, I want you to pick your favorite even number, which is 8. So we're just going to say X equals 8. And I want to know which one of these will represent a odd number, okay? What's 8 squared? 8 times 8 is 64. Is that odd? No. 11, is that odd? Okay, let's go with that. 3 times 8? Is that odd? 8 divided by 3? Is that odd? Decimal, how can the decimal be odd? It's like, you know, 2 point, what did you say? 2.6 repeating?
Yeah, 2.67.
And I'm just going to say that's probably not odd. All right. So do you feel comfortable enough saying B is your answer at this point? And I would agree. Okay.
Just stopped at B.
Well, see, the thing is we didn't actually prove anything. We didn't prove that it's going to be true. Another one of these could have been odd. Okay. But what we have to kind of prove to ourselves is like, hey, B is the only one that worked. So like if we went to C and we got an odd answer, then I would have B and C. And then maybe I have to pick a different number. Because notice Sophie for D got 2.6 and she was kind of like unsure. Okay. So my advice is plug it into each one to make sure to justify to yourself that that's your answer.
Even though it doesn't say you just want 1 or 2 answers.
Yeah, you can only have one answer. Okay, but we're not proving it. We're just, you know, plugging in a number, and you could coincidentally get two answers. Okay? Here, which expression represents the number of cents in D dimes and N nickels? Guarantee you, hope you're getting one like this. I hope this is going to seem silly, but a lot of people forget this. Cents, right? How many cents are in a dollar? 100, very good. How much is a dime worth? 10 cents. Nickel? 5. So up here, all right, seems silly, right? We should be looking for tens and fives, right? Okay, which one are you kind of drawn to? C, all right? So I would agree with you. All right, D and N, that doesn't really make sense, right? If I have one dime and one nickel, my answer should be 15 cents, agreed? And up here I got 2. So I'm drawn to C just because I know how much a dime and a nickel is worth. Are you okay with that?
Yeah.
See where I got? The other way they word this is in like how many dollars, and what you're looking for there is there's 100 cents in a dollar. So you would write it as 10 over 100 or 0.1. Do you guys see where I got that from? And a nickel would be, and they always trip you up with this one. They'll put 0.5 and 0.05. So be careful with that. All right. Emma, can you help me out?
Yeah.
If n plus 7 represents an even number, the next larger even number is represented by what up here?
Would it be
So let me ask you this, Emma. Okay. Here's what I'm going to do. Can you give me a number for n? It doesn't really matter what number.
an even number?
It could be any number. We'll work through it.
Okay, 6.
6. So if n is 6, 6 plus 7 represents an even number. Is that true or false? Is 6 plus 7 even? Emma?
No.
No. So 6 didn't work. So give me one number larger than 6. So what number is larger than 6? One number larger than 6.
10.
So one up from 6, Emma, would be
Oh, 7.
7. All right. So when you chose 6, we got an odd number. So 6 plus 7 was 13. So we want one more than that, all right? Because we want an even number. So if I add 1 to that 6, I get 7 plus 7 is 14. Do you see that, Emma? See how we got to
Yeah.
that? Now, Emma, I'm going to ask you this. N is, we determined N is 7. You kind of found that. N was 7. All right, you wanted 6, 6 didn't work. So we went to 7. 7 plus 7 was 14. What's the next even number after 14?
16.
16. So when I plug 7 into these expressions, which one is going to give me 16? So is 7 plus 8 equal to 16, Emma?
No.
No. Is 7 plus 9 equal to 16, Emma?
Yeah.
Yeah, that's my answer. Now, there is a different way to kind of like rationalize this. Let's go back to Sophie. Sophie, even numbers, right? You said we're 2, 4, 6, 8, 10, right? We're counting by 2s. So I know if n plus 7 is even, count by 2 after that. Meaning n plus 7 plus 2, which is n plus 9. See how there's two ways to do that? So one way is we kind of find a value for n such that it satisfies kind of my constraints. N plus 7 had to be even, so we picked a number such that n plus 7 was even. Emma picked 7, so we went 7 plus 7, and then we plugged it in and we figured it out. If you realize that even numbers are every other number where they count by twos, then the next even number would have to be 2 more than. So we would add 2. Andrew, does that make sense? Think about it. Even numbers are 2, 4, 6, 8, 10, right? We're counting by twos. So we're going up by 2. We're adding 2 each time. Does that make sense, Andrew? So there we go. All right. Nate. Maria is twice as old as Sue. Okay? If X represents Sue's age, which expression represents how old Maria will be in 3 years? This one's tough, right? Because, you know, how old are you? 15? No, that's not right. I'm old. Let's pretend I'm 30. Okay, Nate? Let's pretend I'm 30. All right. Nate, you're 15. I'm 30. I'm twice your age, right? In 3 years, how old will you be? 18. In 3 years, how old will I be? Again, I'll be 33 again. Okay. You okay with that? All right. So it doesn't say double, does it? Right? All right. So let's kind of use that as an express or kind of like food for thought. Okay. So which one of these would be kind of like representative of that? Okay. So will I still remain twice your age? No, right? You were 15 and I am 30. So if I plug in 2, it would be you are now 18 and I would be 33. Okay, let's actually write that down. Nate, 15, Harmon, 30. Feels good. Feels good to be 30. All right, so in 3 years, Nate would be 18 and Harmon would be 33. Okay, so if I plug in 18 to this, all right, I would get 36, and that's not true, right? If I plug this 18 into this, half of 18 is 9 minus 3 doesn't make sense. X plus 3. That doesn't make sense, right? So I'm kind of leaning towards D, right? Because your original age was 15, right? So I'm kind of working through, and I got that. I know it's not exact, but there we go. Sound good? You guys okay with this? So the main point of these questions is this, Kanye. All right, is to pick numbers and plug them in and to rationalize with yourself which ones work out best. All right, I got enough time to do the last one, and that's it. And who haven't I picked on today? Who haven't I picked on?
Oh,
Jordan.
there you go.
You know it's coming. You know it's coming. Jordan.
I would have said 18.
Yeah, that's okay. All day gets harassed in the hallway. Oh my gosh. All right, I'll see you guys tomorrow.
Literally saved by the